Okay, so let's dive into what I think is one of the most important economic stories of our time. It's a story all about technology, about progress, and about how the very source of our planet's power is being completely reshaped, and not by chance, but by a force that's both predictable and incredibly powerful.
Just look at this number, 99.6%. Now, that's not a typo, it's not a rounding error. It's the staggering, almost unbelievable price drop of solar panels, the things that turn sunlight directly into electricity, since the 1970s. We are talking about a technology that went from being crazy expensive to totally world-changing in just a couple of decades.
To really get your head around that, think about your rent. Imagine if your rent had dropped at the same rate. An apartment that cost you $2,500 a month back in the 70s, well, today it would cost you just $10. It's a price collapse so huge, it's almost hard to wrap your mind around. So, the big question is, how on earth did this happen? How did a technology that started out on satellites in outer space become the cheapest source of electricity humanity has ever had? Well, this huge flip didn't happen by accident. Nope, it's the result of a powerful, predictable force that's still pushing prices down today. The answer really lies in this powerful principle, a kind of, well, a virtuous cycle. The core idea behind this whole revolution is something called Swanson's Law, and it's basically the engine that has been driving this incredible progress.
So what is Swanson's Law? It basically says that for every time the world doubles its total production of solar panels, the price drops by about 20%. Now think about that for a second. It's not about time passing, it's about experience. The more we make, the smarter we get at making them, and the cheaper it becomes. And of course, lower costs fuel more demand, which then leads to even more production. It's this amazing, self-reinforcing cycle. And this isn't some magic trick that only works for solar. It's a really fundamental pattern in how technology gets cheaper as we get better at making it. It was first noticed way back in the 1930s by a guy named Theodore Wright, who saw that the cost of building airplanes fell predictably with every doubling of production. What we're seeing with solar is just a supercharged, modern version of that exact same idea. Okay, so here's exactly how that positive feedback loop works. It all starts with demand. More demand means we scale up production. That scale gives us the experience we need to innovate and make manufacturing better. Those improvements slash the costs, which then opens up totally new markets for solar. And what happens then? You guessed it, even more demand. This is the engine, right here, that took solar from a tiny niche tech for satellites to a global energy powerhouse. So, how does this learning actually happen in the real world? It's definitely not magic. This learning curve is driven by thousands of tangible, hands-on engineering breakthroughs, from the way silicon is processed all the way to the very design of the panels themselves. Let me show you one specific innovation that really brings this whole process to life. It's a brilliantly simple idea, and it shows you exactly how engineers are constantly finding new ways to squeeze every last drop of power out of the sun. Okay, check this out. This is a bifacial solar panel. Now, a normal panel only captures light on one side, the top. But some clever engineers thought, hey, wait a minute, what about all the light that reflects off the ground? So they designed panels that are active on both sides, capturing direct sunlight from the front and reflected light from the back. Simple, right? But genius. And the advantage is huge. I mean, depending on what kind of ground is underneath them, these panels can generate up to 30% more electricity. That means you need fewer panels and less land to get the same amount of power, which ultimately drives down the real-world cost of electricity for the whole project. It's a perfect example of the learning curve in action, just a smarter design that wrings more power out of the same basic tech. But, there's always been a catch with solar, hasn't there? A really critical question that, for a long time, has been the biggest hurdle to a fully renewable grid, the elephant in the room, so to speak. Exactly, the challenge of intermittency. Solar power is absolutely fantastic, but we need it at night, we need it on cloudy days. To solve that, you need a partner technology. And fortunately, that partner technology is now following a remarkably similar path of falling costs. The solution, of course, is energy storage, and the economics of batteries are going through their own incredible revolution. Just like we saw with solar panels, the more batteries we build for everything from our phones to electric cars, the cheaper and better they get. And a 97% price drop, that is an absolute game changer. What's so fascinating is seeing how this is playing out all over the world. This table shows the cost of what are called battery energy storage systems, and while the price definitely varies by region, the downward trend is universal. You can see right away how China's integrated supply chain gives them this massive cost advantage. But really, everywhere, the story is the same. Batteries are getting dramatically cheaper, and that's making a fully renewable grid more viable than ever before. So when you combine the plummeting costs of solar with the plummeting costs of batteries, well, you don't just get a new piece of technology, you get an entirely new economic reality. It's a fundamental shift in how we power our entire world. This chart is, wow, it's incredibly revealing. It shows the learning rates for different energy sources. So, for every doubling of installed capacity, solar gets 36% cheaper, wind gets 23% cheaper. But now look at nuclear. It has a negative learning rate. That means for every doubling of capacity, it has actually gotten more expensive to build. This just highlights the fundamental difference. Renewables are technologies that get cheaper with scale, while some traditional sources just don't. So, what does all this actually mean for you? Well, it means we are living through a historic energy transition. And this isn't just about being green. This is about pure economics. We now have access to the cheapest energy in history. That fuels economic growth, it creates massive new investment opportunities, and it offers a path to energy independence based not on digging stuff out of the ground, but on the limitless potential of human ingenuity.
And that leaves us with this final, really powerful thought. A breakthrough in a lab in California or a new manufacturing process in a factory in China, that doesn't just benefit one company or one country. Because of this learning curve, that progress drives down costs for the entire world forever. It's like a shared technological inheritance that's paving the way for a cheaper, cleaner, and more sustainable future for every single one of us.